Hi, welcome to Lagoons Under the Surface. We're excited to have you here today, and we have a guest today.
Hi, my name is Diego Lopez. I'm the chief plant operator for the Wastewater Treatment Plant in the City of Lemoore, California.
And I'm Heather Jennings, Director of Probiotic Solutions. And I'm really excited to have this opportunity to talk with you, Diego, today, because this was a really fun project for me, like most of the time.
I can talk about this subject all day.
Okay, perfect. Well, why don't you start us off?
Sure. I'll just start off by explaining the plant. As you can see there, we have, we'll explain the baseline analysis, how fun we had, you know, finding the baseline. Of course, it's really important to this process. The sampling process, which is my favorite personally. Of course, we'll go through the findings and all of the Sludge Judge fun we had. Yeah, we'll go over how all of that work that we did out in the sun, in the rain, in the wind, and all the mistakes and all of the amazing happy mistakes we made even were all worth it in the economics overview. And so yeah, I'll start off with the pond system here. So we have a very standard lagoon system where our influent consists of about 3 million gallons per day. We average about 2.8 million gallons a day. That Headworks pumps directly into pond 1A and B. And they don't have flow meters, unfortunately. We don't know exactly how much water goes into each lagoon. So therefore, they are very much not twins. They're more like really close sisters. They act completely different to the same water that they're receiving. However, yeah, that's where a lot of our information comes from. A lot of our that's where we directly pump and dose the biostimulant into the ponds there. And they go into parallel, and they go into a series of ponds 2 and 3. They are about 10 feet deep. We have to keep 2 feet of freeboard, of course. And yeah, so there's not very much industrial, activity going on. We have 2 tomato processing plants that don't permit too much water into our system. So it's kind of very agreeable. It's very sort of, it's that industrial input that we get is compatible, I would say, to our lagoon system. So it doesn't, there's not a lot of pollutants and things like that come into our ponds, which is awesome. And yeah, so initially or historically, I should say, they would use a system like a sonar to detect how deep the sludge or how high the sludge is. So what we've done is, get that information, that initial historical information, and we evaluated 3 cross sections from the ponds. We did about 30 points of sampling, 30 to be exact. So it was 10 sections, 3 each. But the analyses that we got, the sampling, I should say, that we got were from 3 sections of the 30. So we'll go into that in the next slides. Yeah, so we started in November of 2018. Is that correct, Heather?
Yeah.
That was the very first. That's when we started the baseline analysis. And so when we started to dose, we started at a 7 parts per million. And then we would, dose that into the ponds, try to get that biostimulant saturated into the ponds, into the sludge layer. And then we would do 5 parts per million after that, slowly going down, of course, not right away, start at 7, 6, and then to 5. And then we did a maintenance dose of 3 parts per million. And then we started doing our sampling. So yeah, this is, the graph there that you just showed, it was an amazing graph. That's one of my favorite things to see, is how you, and all credit goes to you to do those amazing graphics that show very, very closely what it looks like under the surface. And that's what a lot of ponds, pond systems don't, the people who work them don't get. They don't get to really see what's happening under the surface because it's hard to see. So showing that graphic, showing that topographical image is an amazing thing to see, and it gives you a really good idea of like even where your surface aerators are, as opposed to where your tornadoes are. They act very differently, and it closely resembles where they're located, and that's an amazing thing to see where your influence coming in and where your high levels are at. Yes. So the analysis you see here, or the chart you see here, is very interesting. Those are the 3 cross sections there, and they go from east to west. You see the 10 sections there, and then north to south you see the 3 sections that we're able to get. And anything you want to say about these charts?
No,
further?
actually, well, we built that topography from the Sludge Judge, and it was really important for us to actually see what was happening in the lagoon, especially before we started applying products, just to get a good baseline of what the sludge looked like, where the high points, the low points were, how impactful, like you said, the aerators were. So it was actually really valuable to do that. Okay. So let's do sampling methodology. Here's your glorious picture.
Yes. So yeah, what you see there is that Sludge Judge was a creative awesomeness, this ingenuity that our chief plant operator at the time, his name was John Sousa, had an idea to be able to sample each layer. So, as all pond people know, you have your very top layer, aerated layer, and it's fairly clear. And then you have sort of a transitional layer, and then you have the very bottom sludge layer. So each sample point had their transition layer, in different points. So what we did was we simply we modified a sludge judge, just a standard sludge judge. The bottom we cut off in order to keep that little check valve that's on the bottom, and little ball that's down there. And then we just bought clear PVC tubing, and I think we just measured a foot. We just chopped sections a foot at a time, and then we installed these these T couplers there, and screwed in some ball valves, some just quarter turn or half turn ball valves. And so we were able to get 3 buckets labeled bottom, middle, top. And we would also had to sacrifice a tape measure. So we cut a tape measure, we taped it on there, so that way we can get a better idea of of what the depth of the pond is, the depth of the sludge, and things like that. So we got a really great back workout, really great leg workout. I had to stand up, grab it, and it's pretty heavy. This PVC I would say it was heavier, it was thicker than a normal sludge judge, with the water and, with the wind. It was
amazing.
It was
you
awesome.
Did a great job.
We did not have to go to the gym at all. So one time you see me and my coworker Juan, we swapped one day because it was mostly me doing the sludge judging. So then I got to drive the boat, and he had a whole new respect for me because of how tired he was after doing all this sampling. But so it was easy to get the sample from each layer, and it was just awesome. And we only use this again in those 3 cross sections per pond. The other sections we use just a normal sludge judge tubing. So it was just really helpful to do it this way.
Yeah, and then once you guys brought that stuff to the buckets to the bank, we were able to collect samples, and we used a pipette to collect 10 different locations within that 5-gallon bucket. We were trying to get as much composite as we could for every test that we did. Although it was really hard with the sludge
Yes,
pick that up.
a lot of plugged up.
And then you guys,
pipettes.
yes, really gross. And then you guys, you measured the pH and temperature of the field as well. So we could have an idea of what that whole water was looking like.
Yeah, you can see the change per layer in temperature and pH and the EC. You can see it was very emblematic of what was going on as well in those layers chemically. So also just tactile. I was able to feel it. I had to clear that tube, because I would go all the way down to the bottom of the pond, and it would collect the sludge at the bottom of the pond. And for each section or each, some of it was really similar, but some of it was really, you can really feel the grit just all the way down to the bottom. And just to feel with your fingers what the sludge is doing at that depth was really helpful to see the change, to see that once we started dosing the biostimulant, to feel the change in the sludge layer was to me, I was just geeking out over. I mean, I don't know how many people geek out over sludge, but I definitely was one of them.
Okay, Diego, why don't you share with us how we cleaned up the material afterwards?
So yeah, after collecting the material, of course, we washed out the buckets very thoroughly. We bleached them so that each sampling wasn't contaminated with the previous sample. And yeah, just to ensure that we did our due diligence to ensure that we didn't get any cross-contamination on that. So we use usually brand new buckets every single time that we started a project as well. And yeah, just to make sure everything was correct.
Yep, and we almost started with a new motor every time as well, right?
So yes, unfortunately we did have our boat motor stolen. So we had to get a new one that wasn't as easier, as user friendly as we would like. So that was a back workout in itself, having to yank on the starter, on the chain there to make sure it started, because it would bog out depending on how deep it would go. And so yeah, that was not
that's
fun.
not required for testing. That was just part of the plan. Well, and just going on with how we did the measuring of the ATP. So we collected the 30 mil samples. That was the pipette that we did. 10 mils of that we saved for DNA testing, and 20 mils we actually saved for using to measure ATP, adenosine triphosphate. It's basically the powerhouse of all of the cells. And what was really cool is that we could get a total of energy in the system, but also what was dead and what was alive. And then even better, a stress index. And this was actually a novel approach for this equipment. And so we were the ones who established the protocols. So yay us, good job. And it really gave us some really good information later on after we looked at a year's worth of data. And like I mentioned, we sent out for one of those 9 composite samples for each lagoon, so 18 total. And you guys shipped those out from the site itself, correct?
Indeed, yeah. We again bought new coolers, made sure there was plenty of ice in there to keep them nice and cool, and we next day delivered them to the destination, to the lab.
Yeah, and we used Mr. DNA, and looking at like some of these bacterial species that came in, there was over 1,000 of them, depending on the sampling. times. So I just chose the top 20 because they made up 85 to 90% of what was in the system. And then we compared that to the baseline to all the quarterly sampling afterwards. And it was actually really interesting what we found. And how about you do the sludge judge reduction? Because you know the valve dance.
Yeah, the valve dance. I think all pond operators know the valve dance. So we don't have a whole lot of control the way that, say, an activated sludge or a SBR plant does. We don't use polymer. We don't use any of that stuff. So initially, we the ponds were receiving, we could only assume 50-50 of, the effluent from, or the discharge from the headworks. But then, unfortunately, pond 1A was upset for some reason. You can usually tell by either the smell or the color, obviously by the lab tests that you're getting, or the lab results that you're getting. And there was some septicity issues, that was happening in 1A. So then, in order to reduce some of the solids going to 1A, that we had to close that valve about halfway, and so that pond B can handle some of that and give 1A a chance to recover. So indeed, 1B was having a lot of actually good results. It was able to handle some of that, or a lot of that flow going into there, and over time, 1A did bounce back. It was able to bounce back. We were very happy to see that. So after that, after both ponds were good to go, we opened them back up, and yeah, so you're able to see here again this topographical image of post-dosing the bio stimulant. And you can, if you kind of remember the previous image, there's quite a bit of change. We did change some of the locations of some of the aerators as well. And so again, though, you can see where for example, right in the center of pond 1A, this little equal sign looks like that's a tornado. And you can see there where it makes a huge sort of gap, a big
divot.
Big divot. And that's where I was able to feel the grit. Again, I was playing with the sludge with gloves, of course, and a lot of grit. You can feel the grit and how much grit goes into 1A as opposed to 1B, because it didn't feel that much grit in 1B in that same area. So yeah.
Yeah, and I call pond 1A the diva, because if there was an upset, it it was done, it gave up. But 1B was really that workhorse. And the fact that, it went about 10 months before you had to swap it over because there was strain on 1B, that shows you 1B is pretty good. Pretty
Definitely,
effective.
Yes. So we saw definitely a reduction of sludge in 1A and B. And not only that, I also want to again go back to the tactile feeling of the sludge. It was a lot softer. You can feel the way that the biostimulant was making the viscosity a lot softer in the sludge. And there were times where it was hard to keep, sometimes the sludge would plug the bottom of the Sludge Judge, and there were times where the little ball wasn't, maybe something would get stuck in it or something, but the water would fall right out. So I had to, we had to whip right back around with the boat, and make sure we were in the same spot and, try it again. And you can really feel how there was parts of the pond where there was absolutely no sludge layer. So even though we were reading off the measurement of where the sludge or the transition layer was happening, there were times where I had to say, there's no sludge here. And that's super rare to say for any pond person to say there's no sludge here, without dredging, without any of that kind of stuff, was just amazing.
Yeah. the numbers, it's a little easy to see where all the zeros are here.
There they
Okay,
are.
1B, yeah, 1B didn't have as much, but it was carrying more solids. So I'm willing to forgive 1B. It did a good job. So you want to cover pH as well?
Indeed. So again, you can see, and I'm gonna need your help with this one as well, but you can see on the, for example, just the first column there, 1A1 top, 1A1 medium, and 1A1 bottom, and how the corresponding pH tends to, it will go lower on that one section there. And, you know, that goes to the characteristic between each layer and the anaerobic, you know, condition versus aerobic condition, you know, how that affects pH. It affects temperature, it affects EC as well. So,
yeah, and I mean, it's logical now that you think about it, but it was actually really cool to just collect that data and see just how anaerobic, how much that was really impacting that pH. You know, by the time it goes out, it's pretty neutral, but there's times where it's acidic. That was kind of cool. And you know, something that I thought was interesting with the temperature as well is, you know, even though these ponds are 10 feet down, that the bottom layers were really close to ambient levels. I thought that was kind of surprising. You're like 10 feet down, it must be so much cooler or whatever,
right.
but it was pretty close to ambient. So, you know, we got some, you know, into the 60s in November and so forth, but you guys were able to maintain a pretty good temperature throughout the whole system. Not that you did anything for it, but you know, I just thought that was really interesting.
Indeed, yes, definitely.
Okay, so like I mentioned, we did 18 samples when we measured that ATP, and the supernatant was that top layer, interstitial is the middle layer, and the sludge layer was the bottom layer. And what we found with these graphs here, you can see the middle and the bottom go to the bottom there. The bottom layer actually had the most bioactivity. I can't tell you how many times, you know, I've talked to different operators, and they're like, oh, it's dead, you know, and you can't do anything with that layer. They just need to dredge it out. And here we're finding data saying, no, it's actually really valuable. You're going to get treatment because there's enough bioactivity there. Also see where in January you had that pH swing of 6 and 9 that came in kind of out of the blue on you guys, and how that impacted the bioactivity. It just really hit 1A really hard. 1B not as hard, except for the bottom there. And then we got recovery during the summer. Now, we were starting to think, oh my gosh, you know, we're losing activity throughout here, but some of these areas, there was no sludge. And if you don't have the sludge, you don't have the biomass there, then you're not going to have activity. So we had to start thinking about that as well, which was something I didn't anticipate actually. Or maybe I should have, but that was a, you know, lesson learned. Very interesting, I think. And then we come to the DNA. And now in November, we did the DNA analyses. And primarily, you guys had just tomato plant bacteria. Those were your primary things we had there. And of course, that doesn't do any good for COD, BODs, organic consumptions. And that was primarily from the tomato processing you guys had that season between June and August, isn't it?
I believe so, yes. Very, very heavy. And you can even smell in the atmosphere the spaghetti sauce and the salsas. And yeah, and I think just the population also loves spaghetti.
Well, yeah, and who doesn't? And what was interesting is that we were able to, you know, months later, see a difference in it, but then we had that toxicity issue as well. But even despite that, still able to see Acinetobacters and the Pseudomonas fragile and syringae and so forth that were coming in and taking over. Those are the BOD consumers, the ones that you want doing the job. And that was pretty exciting. And then as we go through, August, we were getting a lot of diversity in the system, a lot of different bacterium operating. And then November, during the turnover, November and May had turnover times, and you can see things, coming back up to the top, but still we weren't losing all of that population like you were before. I mean, really we weren't where you started. In the baseline on the left to the DNA testing on the right a year later, a lot of change in the system, I think, and for the better.
Yes, that's so cool.
I know, I get excited every time I see it too. I nerd on that. And so we also looked at the nitrifying bacteria. We're getting, over 5 times the amount in May, and almost that much in November of 2019, despite the hit that came in during the January, February timeframe. But then we had something that came in during August that wasn't detectable in the normal operations. It wasn't a pH that we saw, at least from the operating data, but still something came in and impacted the nitrifiers. And I think it's important to remember that, the nitrifiers are the divas of bacteria as well. So you have divas in a diva pond, but really you got that recovery back. And that's what's exciting, is getting that recovery and getting those species and diversifying the species so that you're really getting some treatment. Okay, so let's talk costs. So on average, 45% sludge removed. And we also took into account the amount of sludge that didn't settle, that came in and was treated on top of what you were dredging at the same time. And then we converted that to dry tons, and then converted that to money, because really that's what it comes down to. And the $340 a ton, dry ton, came from you guys. You'd had a previous study. And once we did the multiplication, we're like, wow, that looks like 6 million. But when you start thinking of it being 2 separate ponds that were getting that treatment, 6 million really isn't that far off. And we excluded downtime required to dredge simply because we didn't have to take the ponds down. So that wasn't part of the calculation. Now, I put the 2-year costs here, but compared to the 6 million, really came in under 6% of your total dredging costs. And to me, that's very exciting. We usually tell people 10% or less of a dredging cost to remove stuff. So you can say how you feel, Diego.
Well, I mean, for me, even as an operator, or any operator, any treatment plant, really has to answer to the ratepayers. And so, for us to provide savings and for us to just, do what we can with the least amount of cost possible, because we have, a lot of different things coming at us with new technology, with the more stringent rules coming from, the states or things like that. We have to usually spend more on technology in order to, to meet certain requirements from the state or from other, entities. We have to ensure that we do all those things and keep the ratepayers in mind. So to see the savings like this, and it was all worth it. All the back workouts and all the playing with sludge was totally worth it, definitely, to see this information and this transformation.
Yeah, and I really appreciate, as not only as a vendor, but my background being in chemistry, having the opportunity to go through and really evaluate this and then see that cost savings with it. That's pretty exciting to see, it makes a difference. And really all the dosing was a peristaltic pump, and you guys kind of covered it up, protect it from the elements, and then it just did its thing. And there's no sexy stainless steel.
It
But
was
it's very
very,
simple.
yeah, it was a very simple system. You just, just let this pump go, and we did have to, switch out some tubings, things like that. Because it was out in the elements, there was a little bit of brittle plastic that we had to replace, but it was a very minimal maintenance. So it worked out really well.
Yeah. Well, I greatly appreciate it, and I had a lot of fun with you guys out there, and we just appreciate your time.
Likewise, you're always welcome back for any other research you want to do.
Okay, sounds perfect.